Hello, everyone. Let's make sure the YouTube stream is up and going. This is the second day of the complex analysis reading group. We had to cancel. I had to cancel last week because I ended up being out of town. But we're back at it. So last time we got through everything for 1.2. Slim. Thank you so much for the raid. I hope your stream was good, Slim. Enochian, welcome in. Oh, I forgot to pin a message. For anyone who's new here, I'm Don Factorial. Until like last week, I was Don Does Math. On Tuesdays, I do this reading group for complex analysis. It's literally just like about to start now. I haven't even jumped in Discord yet. Where we go through this book. Oh, nice. And I forgot, I usually pin a message, and I need to figure out, I should really just get a bot to post this. This is a reading group on complex analysis. It happens on Tuesdays. We're following complex variables by Ablowitz Focus. 2Z, thank you for the follow. Yes, Slim. Normally I just do like homework help streams. For I equals 1 to n, do n factorial? Is there a formula for that? For the sum of factorials? Isn't that just n factorial? No, that's like n factorial times. That feels like 1/2 or something like that. Okay, you're just being oh, I get it. Yeah. Okay. I do think that you can get some kind of formula for the sum of factorials, though. Anyway, I'm trying to figure out a message to pin. But yeah, I do math homework help. I have 2 reading groups going where we get in Discord and solve problems together and talk about the content from whatever book we're following. And I also stream video games. Daisy is a mainstay, and then I usually do a second game that's kind of rotating. And I can't talk and type at the same time. So on Tuesdays, I listen focus. We discuss the content of the chapter and solve problems together. I may be slow to respond to chat. So as to not cut off the conversation. Okay. Nice. Okay. So, actually, I'm going to hop on Discord. And we'll see who wants to join. Slim, you're more than welcome to join for any or all of these, obviously, but if you ever just rest after doing a stream, that's completely understandable. Yeah, we'll see who hops in here. Stooky, sum from 0 to n of I, or n factorial. Oh wait, oh no, of I factorial is approximately n factorial times e. Ooh, maybe. No worries, Slim. I get it. Usually, last thing I want to do after a stream is do more math. Yeah, and okay, yeah, there's Fembox. Hello.
Hey,
Hope you're doing well.
doing good. How are you doing?
Pretty good. Just kind of running around all morning, just doing like random stuff, but I'm here now.
Yep, random stuff has to be done.
Yeah. Okay, so last time we talked, we got through all the questions I chose for section 1.2, so we'll try and get through the ones for 1.3. So the schedule is posted in the usual spot, and I'll bring in question 1. Question one has a bunch of parts. I was thinking, I said A, D, and F might be a way to not have to do a bunch of work. These seemed different enough from each other and still interesting.
Ooh, limits.
Right, and so these are like they're like multivariable limits, right? So they're a little bit more difficult.
Oh no! Don't tell me we got to do epsilon delta.
No, I don't think that's it. But we just have to worry about like
All right.
what direction things come from. I really should have read back through this section of the book before doing this, but you have to evaluate the following limits. Well, I guess for part A, we can the limits to I, so we don't actually have to worry about discontinuities, I don't think. Like, I think we just plug in I and we're okay for part A. I guess we can simplify this. That becomes minus I. Oh, do we just get 0?
Interesting.
Huh.
Oh yeah, 1 on I is minus I. Yeah.
That's kind of weird. I wouldn't feel like that should be 0, but it is.
You know, if you set that to 0, z plus 1 over z, if you set it equal to 0.
Oh.
Yeah. And then you multiply by z, you get z squared plus 1 equals 0. So
Oh, yeah.
that actually makes sense.
Okay. Need a screen list tablet for math. Oh, nice. I mean, that might still work for math too, you know, Gimbet. I definitely have a screenless tablet, and it's pretty great. And then part D, I was thinking A has way too many parts to do well, so I was thinking just do A, D, and F. Lucas, if you can catch Jasu, I know she likes biology, or actually, I think she well, I don't know. I don't know about likes, but that's the only person I can think of who might know. I'm gonna z goes to 0, sine of z over z. This one seemed kind of interesting because I wonder how it's gonna be different from sine x over x. So I wonder if we want to think about. I wonder if we want to make the sign into e's.
Oh, good idea.
I'm gonna get this wrong, so I'm just gonna look up what the complex definition is. Ugh, where is it? There it is. Okay. E to the I z minus e to the minus I z over 2I. And I guess we'll say. Oh, no, wait. Here we need an R. No, wait. Z, yeah. Wait, this feels. Maybe I should just keep that as a Z on the bottom.
I guess. Yeah, I guess.
Okay. What's happening? I guess maybe this is a good time to split up into two fractions. I forgot to. I would get marked off points for not writing the limit each step.
Isn't that a pain?
It really is. The worst one is with improper integrals because it takes so many steps And you're technically supposed to have the limit from the very start, I think. I just never do it, though. Okay. I feel like this limit is gonna... Well, at least if these were real numbers, that limit would diverge.
Hmm.
And this one would go to 0.
I feel like this is going to have no limit.
I mean, I'm getting infinity vibes, I guess.
Slim says it's 1.
Hmm. Yeah, I mean, I guess the like we could think about like that's true. If we wanted to
Oh.
disprove it, like we could find a limit value that doesn't end up with 1.
Yeah, Hamiltonian. I'm thinking that too. Like, let Z be U plus IV. And could we do an angle sum for the sine? Does that help?
Oh,
Maybe that's
I was interpreting that as like a Taylor series
okay.
for expansion, which maybe that could be a better idea than what I was doing at least.
Oh, yeah, that's a good idea.
Uh, what is this series though? I forget. It should just be the odd part of E. Okay, yeah, it is. So
It looks the same as for a real variable, I think.
yeah. Okay, yeah, got the copy down right. Divided by Z. Okay, well, we can bring the Z on the bottom inside the summation.
Oh, so this will be 1. Will it?
I'm not
Yeah,
seeing it yet, but
1.
maybe. Is it going to turn into cosine just with a different coefficient? Is that why? Yeah, I feel like we need to somehow mess with this so it turns into cosine.
I think the easy way to see it is just write out the first 3 or 4 terms.
Oh, really?
Yeah.
Oh, just do Z equals 0 for the limit. Oh.
Yeah, because I
Oh. Okay. Yeah, but I like what you said, Felix, with writing out a few terms, because that's we need the constant term.
yeah.
Or there's gonna be a term without Z's, I think. Uh, so if J equals 0, we just get a 1. And then everything after that is going to have a Z inside of it and will be 0. Okay, so we just get 1. Nice. Good call, Hamiltonian dynamics.
Yeah.
And then the other one from number 1 I thought we could do was part F. So Z to infinity. Z squared over 3Z plus 1 squared. And I feel like maybe we can just do this like it's a regular polynomial. Like we could multiply this by 1 over Z squared over 1 over Z squared.
Nice.
I guess. Part E is interesting too.
Yeah.
Yeah, we could, these are going pretty quick, so we could do E as well if you want, Bluebird. Sorry, what? Pinlocks?
I'm just saying I like your approach here. Yeah, part
Okay.
E does look good.
Okay.
Or hard, anyway.
Let's try then. Once we get through this, it should just be the coefficient thing. Or like the leading coefficients. I guess. 9 plus 6 over z. It's 1 over z squared. So we get 1 over 9. Hey, Jonathan. Okay, let's shift F down to give us room for E. So same as before, or it's same with sign, but to infinity. Could we use the same logic to say it's going to diverge? Kind of minus. Well, no, it's alternating. It's not that simple. Slim is colon 0. Hey, Enrid. It's getting a little crowded. Let's just space it out. Yeah, the J's got decapitated there.
Yeah, a little rogue dot.
Yeah. And so I assume that going to the actual terms wouldn't be that helpful, so we're going to get infinity minus infinity. Oh, here's some is thinking what you said before with the addition identity. Hey, Tuzi. We are... I think that should still be true. I don't know if it's helpful. Sony Dynamics doesn't like the expansion. I don't think I like it either.
I don't think there is a magnitude bound on sign of a complex number, is there? Isn't it that you can make it?
I honestly couldn't tell you. I'd have to play with it.
I'm pretty sure sign of a complex number can be greater than 1 or less than -1, I think.
Hey, Tyler.
In fact, I feel like Zach did one of those today on his stream. He did
really?
like sign of z equals 3 or something.
Okay.
Yeah.
Oh, I might have seen that. Okay. So I guess let's investigate the sum identity idea then. Oh wait, does it seriously include hyperbolic functions, Slim? When it's complex? Oh, I think we skipped over looking at this identity. I think it was like one of the problems. You think so? We should...
I got a cheat sheet of all these somewhere.
Oh, I found it. Sine x cos y by cosine x sinh y. Yeah, you got it right. Okay. Newtonian dynamics suggesting an interesting looking change of variables. Sine x cos y I cos x sinh y. plus iy. Oh, I shouldn't be writing z goes to infinity anymore. Best way to learn C is find a Saudi student that is failing his grad math program and so desperate to give you half their stipend to work through the entire book with. Is that a reference to something? Uh, Maybe we split this up into two separate fractions. And we can deduce something. Well, I was thinking about this because it looks like this is basically sine x over x and cos y over y as these go to infinity. Like, and think about them as a product. Hey, Grim. I guess this would end up with 0, though. I don't know if that's expected or not. By my logic. All right. Maybe we'll try Slim's idea. If the limit is actually 0, I feel like what I just did here is legit, but I'm not completely sure. Just transfer that down. Approaching infinity along the x-axis, letting y equal 0, and similarly along the y-axis. In Hamiltonian dynamics, you might raise a good point there. I don't know. I I think this is okay too. They both go to infinity. Bluebird. I'm trying to. Sorry, there's a couple different paths that are being suggested now. I don't know which one is the best one to go down, but
Do we get two different answers along two different paths? Because that would be,
I assume that's the point of what Bluebird's saying.
yeah.
Cinch of 0 is 0. So that just gets a 0, I think. The first term there is 0. I assume this is diverging.
Yeah, because e to the y is, yeah.
So this seems to shade. It says the limit wouldn't exist, I guess, but huh. I'm not sure what to think about that. Maybe I'll keep plugging away at Slim's idea. In the back of my mind, I still have a Hamiltonian dynamics talking about polar form. Um, assign an entire function. If so, is the Laurent series the same as the Taylor? In which case, here you get limit. We haven't gotten to Laurent series yet. Honestly, no, I couldn't tell you.
That might be the limit as we go to 0, though, instead of the limit to infinity. Because we did get 1 for part D.
Yeah. Hey Beast Gaming. Oh, the wrong limit. Okay.
Yeah, Slim. I think Lubert found a reason that we sort of found a counterexample, right? Or found a reason for us to believe there is no limit.
Yeah, I mean, if I guess theoretically we could probably back up and like think about it from earlier too, before even split the sign up, and would we get 2 different results there too? I don't think we would. That's weird.
No, I think you do, because sine of I times y, I think is I times hyperbolic sine of y.
It is.
Or something like that.
Yeah, there's an identity that's like that. Yeah, sine of iz is equal to I sine z. Or sinh. So could we have saved ourselves some work and even earlier on here, just done this? That's gonna be I sinh y over IY. And that's still diverging, right? Infinity?
Yeah.
Okay. I guess it doesn't exist then. Yeah, Bluebird. That's kind of a funny one. That's how I'm interpreting it, Dr. L. That the magnitude is getting infinitely large. They probably say it more formally somewhere in here.
Weren't they talking about it in terms of like 1 over z? Like you define z going to infinity as like 1 over z going to 0? I seem to remember reading that somewhere.
I feel like something somewhere talked about that, yeah. Hey, mouse. Yeah. Okay. Interesting limits. Lubert, thanks for calling out. Or E. Tyler. You sure can. In other words, does limit z go infinity imply both x infinity and y infinity? Yeah, I think you can. I assume any combination of x and y, as long as the magnitude goes to infinity, I think you can accomplish that however you want with x and y. Beast Gaming, I'm American. Okay. Next one I had picked out was number 3. It's like they're saying except delta gets large when we consider all z greater than delta. Okay. Yeah, Milk, like, are we going to infinity? It should be the same result for any theta, I would think. We're locked. Actually, I don't think anyone claimed first, so someone can do it quick. Okay. Bizba's got it. Luber saying for z to infinity, you always think of taking r going to 0, where r is the radius of some small circle centered around the north pole of the Riemann sphere. Huh. You'd have to do some kind of like change of variables or something to actually reflect that, right? Peace Gaming, I visited. You were first. We can say that hard locked. Hope you're doing well. Okay, so if g of z is bounded by m, and m is a positive number for all z in a neighborhood of z equals z naught, show that if the limit as z approaches z naught of z equals 0, then the limit of their product should also be 0. So I think as long as g doesn't diverge, the limit should always go to 0 is what this is saying. Can we just like squeeze this?
Maybe. Except squeezing. How do you squeeze in complex? Because you've got like an infinite number of directions to squeeze. Maybe not. Maybe not. You're thinking of squeeze the magnitude is what you mean, right? Like squeeze the.
Oops, not that.
Yeah,
I mean, these are
the
just like scalar numbers, right?
Yeah.
Let's see. The magnitude? Well, what's the relationship with... Hmm. the limit we want to say is something about doesn't involve magnitudes. Like I can't. Well,
Yeah,
okay.
because
Like I would want to say that this limit is bounded above by like the magnitude or something, but that makes no sense. Um,
yeah, to order them, you have to put a magnitude on it, don't you?
yeah, you're right. It doesn't make sense to compare. Like you can't say 1 plus I is less than or equal to 2 plus 2I or something. That is that like your concern?
Yeah.
Okay, that's fair. So we do need to talk about magnitudes. Um,
So what if you wrote it
maybe
like write it
Hamiltonian
without the
dynamics.
limit? Basically what you had, but without the limit sign.
Yeah, and
I'm gonna be super picky and change this to an equals.
uh
It's not wrong, is it?
oh, they would be equal. You're right. Okay, you're right. This isn't quite the triangle inequality, is it? um, okay, and then I think the point is we can take the first two things and the last thing and do like evaluate the limit. Like this is our squeeze.
Yeah, cool. Yeah, squeezing it. That was a good idea. Yeah. Yeah, good idea.
So,
Good idea.
and I think this would only work if it goes to 0. Like if it was just a number, I feel like this argument wouldn't really work with magnitudes.
Yeah, I think you're right because yeah, if that had been a 1,
It could be like any complex number with magnitude 1. So maybe it's still possible it's just to like work to do or something. I don't know. But I think the magnitudes going to 0 means that the limit itself without magnitudes also needs to be 0. Okay, yeah, and some just put that there. Modulus is continuous. Ooh. Really? It's kind of funny. Okay.
so basically if the size of a complex number goes to 0, then the complex number itself goes to 0. I mean, is that what that says? That seems clear.
Yeah.
Yeah.
Okay. Nice. Next, I grabbed number 4. This one has a bunch of parts as well. I was thinking we can do just A and C though. Unless, I mean, people feel free to color ones that look interesting. I'm just do my best to choose ones that seem interesting, but I don't know. Okay, so where are they differentiable? And I assume they want us to do the limit definition. Limit as delta z goes to 0. This I remember seeing Zach talk about today. That's the line definition, right? So I assume for sine, it's gonna, I imagine it's gonna go like the proof for the real version of sine. Like we're gonna use the sum identity. Oh wait, but the sum looks different for complex. So we might end up needing a different argument. Sine x cos y. Sine z cos delta z plus I cos z sinh delta z.
You might have missed an H here.
I sure did. Thank you. All right, now what happens? Ooh, that limit right there is diverging, I think. Oh, wait, no, we can factor the sine z out. Okay.
Yeah.
Oh, wait, but it's gonna be cosh though. Hmm. Oh, hey, the delta z is canceled from that fraction.
I don't think they'll cancel because that's inside the hyperbolic sine,
You're
isn't
right.
it?
Ah, I don't know math. I should have put my parentheses. Okay, but we already no, we did. That's sinh, not sine. Uh, Interesting. I was guessing sine is differentiable everywhere. It has that vibe. I mean, it's just a combination of e's, right? And e should be differentiable everywhere. Is that a better argument? Oh my god. Wait. Maybe Taylor series is a good call too, but if it is a combination of e's, can't we just say that e is differentiable everywhere? I don't remember if the book actually ever showed that, but
Oh, there it is. Derivative of sine is cosine.
Oh yeah. They don't necessarily say where.
Ah,
But okay, yeah, I think I want to throw out this this whole thing here. uh yeah, thank you, Slim. That's what I use. Um what I'm using like right this instant to collaborate is excalidraw.com. But if I'm just on my own, I do Journal++. Um uh okay. It's an even number. I was kind of curious if the book, like, what argument they would make. But that's always something that we could Google, I guess. It just feels like too good to be true, almost. Okay, so part C, they give us a rational function. Well, I don't know if it still counts as a rational function for complex, but rational looking. Um, I'm trying to think of like ways to manipulate it before working on it, but I can't find any cancellations. Doesn't make sense to try to. We can't really like divide it.
we could factor that denominator.
Yeah, I mean, but that'll be z plus I and z minus I, right? I mean,
Yeah.
partial fractions. I don't know. Maybe. Cauchy-Riemann in the next chapter? Okay. Someone's calling everywhere but 1 and minus 1. Really? Not I and minus I?
Yeah, I'm gonna say everywhere except I and minus I.
Uh,
So is it like in real numbers where differentiability implies continuity? So if it's not continuous, then it's automatically not differentiable, right? I think I remember reading that.
I think it does work the same way where it's not necessarily the other way where continuous isn't always differentiable, but I think the other direction, I assume it's got to be true. I think it just can't be. But if we need to actually like show it, because we haven't given a rationale yet, I assume partial fractions is something we can try to do to like simplify it before trying to do a limit.
Cool.
Uh, A plus B. Nope, go away. It's 1. Oh,
Is that a plus IB?
yes, it is. This seems. How can two purely imaginary numbers add to a real number, though?
Well, A and B are going to be complex coefficients here.
Oh, okay, yeah, fair. Just last week, Krim. Okay. I guess we want to multiply this through by I. And then add the two equations.
They add up to 1 and their difference is negative I. Yeah, there you go.
I guess, yeah, we can subtract them too. Okay, that seems reasonable. Yeah, okay, that works. So I don't know, like, do we have anything to tell us? Like, I don't think we ever looked at 1 over z as far as being differentiable. Nice try, Anders.
What was that thing we did last time with 1 over z?
Uh, we we just analyzed it as a transformation.
Hmm. Okay.
Yeah, no, I assume now we have to go to the limit. I don't see what else to do here. We can do it for just one of them, and the work for the other should probably be the same, though. True, Anders. Hamiltonian, if they're asking where it's not differentiable, I'd like to have some type of work that would, like, I and minus I seem like obvious problems, but I'd like to have some type of work to, like, justify why it is differentiable elsewhere.
Oh, Luber, they did say something like that.
If f and g are differentiable functions, f over g is differentiable, g is not 0.
Yeah, didn't they
Oh,
say that?
really?
Something like that?
That would be nice.
Yeah, page 25. Yeah, the third formula on page 25 there. I think that's telling us we're good as long as the denominator is not 0.
Huh. Interesting. Okay. Okay. That's way easier than what I was doing. uh
Yeah, but there's always time for partial fractions. I mean, come
is
on,
there?
they're fun.
I'll
Yeah.
leave it there, I guess. That might be the least fun type of problem. I'll put an X through it, but the work will still be there. Let me shove it out of the way a little bit. Okay. Maybe I'll just take a screenshot of the quotient rule, and that's our justification. What? Oh, I pressed undo. Or did I? I don't know what I did. So it's differentiable everywhere. Except z equals I and minus I. Oop. Okay. That's number 4 done. Well, at least the ones that I was planning to do from 4.
Killing them.
Yeah, this is going much smoother than relativity. To be fair, this is still chapter 1. And by the way, guys, the Discord call is open to anyone who wants to hop in. All right, f of z is continuous function for all z. Show that if f of z naught is not 0, then there must be a neighborhood of z naught in which f of z is not 0. Okay, what does continuity mean? It's first thing. I want like the epsilon. Delta type of thing. Oh, you know what? Okay. They do say that if the real and imaginary parts of f are continuous, then the complex function f of z is continuous. And I assume we could use that fact and whatever the normal proof is for real numbers to do this.
Okay, anybody good at real analysis?
Nope. So it's not continuous there? Wait, what? For every epsilon greater than 0, there's a delta greater than 0 such that when magnitude of z minus z naught is less than delta, the magnitude of f z naught minus f z is less than epsilon. From falls directly from that definition. Oh, okay. Sorry, Hamiltonian dynamics.
Oh, yes. I see it here. Let this be epsilon.
Epsilon equal to f of z naught. Oh, it is number. Well, it's not 0. Okay. Wait, so it is epsilon. Epsilon's still a real number, right? Okay, yeah, because we're talking about a magnitude. Yeah, that's where I was getting confused. uh. Okay, and are we gonna triangle inequality? Which direction does it's gonna be less than, oh no, that goes the wrong way though. Or wait, no, this if they're subtracted, the triangle inequality is different. No, is it? No, it's the same. I guess then there exists a delta. Uh, no, is this epsilon equaling f of z naught? No, wait.
Yeah, I think I get it a little bit.
Okay, because I'm a little lost with this choice of
Let's
epsilon.
let's say we got this circle here. Here's z naught. And a circle over here. Here's f of z naught.
Okay. Towards the neighborhoods of each.
We want this to be radius delta, this to be radius epsilon. Is this right?
Yeah.
We want to choose a z in here somewhere. So let's see. For all epsilon, there is a delta such that if I choose a z inside this circle, then the f of z has to be inside the other circle. So the f of z is going to land over here somewhere. So here's my map, right?
Right.
So if it's a continuous function, sorry.
Hey, Phobos. Hey, cheap tattooed officer.
Yeah, did I put the z0 in the wrong place? Let me see here.
No, z naught is right. That's our center. And the regular z is anything in the neighborhood.
There must be a neighborhood of z naught in which f of z is non-zero.
Zero is outside the second ball, so f of z cannot be zero. Well, we know f of z naught isn't zero. I understand intuitively that this neighborhood should exist. I'm just I'm just not sure how to show it.
Oh, so yeah, I didn't draw my axes, did I? So should this? So if I did a, so should zero be on the boundary of this second circle, or should I make? Let's see. So you guys are saying we want zero out here somewhere. We just want to make sure that circle doesn't touch zero. If I let epsilon be the magnitude of f z naught, Then wouldn't that, if I did that, then wouldn't this one have come like this and come through there? Maybe it doesn't really matter. Yeah, because it's an open neighborhood, isn't it? I think I get it. So Slim, you're saying I could put the 0 here, for example, like on the boundary. Because this is less than here.
Oh, that's what this choice epsilon is doing. It's putting 0 right on the boundary. Okay.
Yeah, I think so. Yeah, let's do that. Just put it, I don't know, here. And these should be dotted lines, shouldn't they? These should be dotted circles, I guess. Well, we're only concerned about what's inside the circles, not on the circles.
Mm-hmm. Hey, Dr. Hill.
Well, I guess then we're done, right? I mean,
Yeah, I mean, I understand this picture way. I'm looking for the annoying proof way, I guess. And
well, isn't what you wrote just the same as the picture? I think it's the
I
same
guess
as the
it is.
picture.
You're right. I guess we're kind of done as soon as we let epsilon be that. Like, there must be a neighborhood. So, like, we could choose, like, delta over 2 or something, or, like, some z that would give you, like, delta over 2, plug that back in, and get something that's non-zero. Okay. I know, I'm kind of curious just to see what the reverse triangle inequality gives us. Um, greater than or equal to. And so this thing should also be less than epsilon. Yeah, we can always just flip it around. Oh, I mean, okay, yeah, the way I wrote it isn't. Sure. I just undid something I didn't mean to do.
Oops.
But then if we let epsilon equal f of z naught, I'm just gonna, without making too much of a fuss about it, I'm just gonna get rid of the outside absolute value. Don't we want this to go the other way? We know if f of z isn't 0, or f of z naught isn't 0. Yeah, Cytos. I changed it last week. Yeah, I mean, I guess this just feels weird that we can prove we can apparently prove both directions of this inequality. I feel like there's some weird like there's a weird thing that's happening here. I thought the plan was to let epsilon equal f of z naught, or like I thought we were letting these two equal each other. And I realized that we could just flip the order of these two things, and that's also true. But I feel like we're changing that we're getting two different results depending whether we change it or not.
Yeah, how'd you get this one here?
Um, so I was taking this epsilon greater than this piece, and then I
Yeah.
let epsilon equal the magnitude of f of z naught.
Oh, I see.
And so because
Yeah,
they're
maybe
absolute
you
values, we could swap the order, but that just feels wrong. So you're right.
you,
Like I got rid of
you still
those.
need these ones?
I thought we
Maybe you
didn't,
still
but
need
maybe we
those.
do. Yeah.
Yeah, because I feel like we don't know which of these two things is bigger, right? Kind of depends where Z is.
Yeah. Hey Matthew. It was pointed out to me. I hope I've been pronouncing your name right. I realized I never asked you. I'm doing good though. How about you? I can do something like this if x magnitude if the absolute value of x is less than 10, right? Less than it's I think I have the reverse direction for the or for the inequality as you Lubert. Epsilon greater than or equal to f of z naught minus f of z. That I don't know, something about some just feels weird to me. 6 math exams this week? Oh my god, that's crazy. Good luck with those. Um, okay, I'll show you the exercise in a second. Hamiltonian dynamics. Let me just fill in what the work is. I said epsilon is greater than that, and then I set epsilon equal to that. Is the are the lines that I didn't like fill in there. Yeah, it's number 6 from section 1.3. It's right there. Actually, I can put that's copy and pasteable. Yeah, just find in the book. Yeah, the like as soon as I read the question, I understood intuitively that this is going to be true from something that's basically like the picture that Fembot's drew. I just assume that in like an actual complex analysis class, they're not going to accept a picture for the answer. uh, I think the continuity piece was letting epsilon equal the function value. Is that it? Hey, Rightel. Differential geometry? Oh my god. That's crazy. Okay, I mean, I just don't like that. I know with absolute values we can flip the order of these two and then we get something that's good. I just don't like that we can prove two different results with the same argument. That's what makes me uncomfortable. Yeah, right now.
Well, yeah. Are you saying we're proving two different sort of contradictory things?
Yeah, I feel like
Well, that's no good.
because I mean maybe I should think more about what Lubrick was saying, where we could split this absolute value into like two separate inequalities.
Yeah, I was trying to think about that too. But I still feel like I don't know which way to write those two because I just don't know which one's bigger.
Um, I think we would like assume one and then assume the other, and hopefully, well, I don't know. Hopefully, get the same result, but I don't know that we would. If f of z is the bigger one, so that in one of these the inequality will flip, and that presumably would save it.
Okay, so go by cases.
Oh, someone wants to join the voice. I need to. Oh, I need to give you the role again, I guess. You should be able to see it now. It's called reading group.
Oh, hey Don, how's it going?
Slim, it's going good. How about you?
Have you missed my lovely voice?
I did.
Hey, Slim.
Hi. Yeah.
Fembox here.
All right. So, so what is the thing that is confusing you?
I just don't like. So you're saying that we can flip the order of the f of z and f of z naught with reverse
Yeah, because
short caveat?
so do you agree that you can flip the order before you take away the absolute value? Like,
Yeah,
Yes.
I think we can only do it before we take it.
yeah. So but is it true that if you have a number, like let's say you have any number and you take the absolute value, is it true that the absolute value is larger than the number, or not?
Yeah,
Well,
or equal
greater
to,
than
but
or equal.
Greater than or equal, yeah. So you can flip the order before taking the absolute value, right? And then you can say that whatever is inside the absolute value is smaller or equal than whatever is what is inside the absolute value, right?
I think I got you there. Yeah.
I didn't catch that last like sentence.
What is the? Let me check. Can I get into the?
Oh yeah, in the text chat for this like voice chat, it's a
Okay.
weird spot, but yeah.
Okay. I'll get there. I'll get there. I guess what I'm saying is. But and by the way, if you can do that, you agree with the proof? Like everything else is kind
Yeah.
of clear? Why isn't it letting me? Okay.
Are we just saying we can do this then?
Yeah, I'm not in.
Like that, maybe?
Yes, yes, but you want it in the other order, right?
Oh, reverse it. Reverse it. Oh, I see.
Yeah. Mm.
Okay, well, that's easy to do. Let's reverse it. Oops.
Get rid of
Yeah.
my
Oh,
stuff down.
did I do that?
No, that was me because we're doing this now.
All right. So I think I found.
Oh yeah. Can see
So
you.
so that first reversal that Famebox just did, that's legal, isn't it?
Yeah.
Yeah.
And then if after that to the right you put a greater or equal than whatever is inside the absolute value, that's also legal, right?
Yeah.
Oh. Okay.
All right. And now from that you deduce that f of z is strictly greater than 0 because the f of z zeros cancel in both sides, and then you move the negative to the other side, right?
Okay. And that flips the inequality. Okay.
Yes, exactly. And the inequality is strict, right? Because you have the first inequality is strict. The second one is greater than or equal to, but the first one is strictly
Yeah.
greater
Yeah.
than.
Yeah.
Right.
So
Yeah. Oh, man.
Okay.
You know, I've just always been very, very poor at inequalities. I love seeing equal signs. As soon as I see a greater than or equal, I don't like it anymore.
Yeah.
yeah, I think honestly it's this thing where like the visual is very clear, but when you try to put it into symbols, you start getting easily confused. Because the balls that you
Yeah.
draw at the beginning, they are very clear, and this is exactly just putting into mathematical symbols the drawing basically.
Yeah, and I was insisting on trying to do this because I would like to be better at this part of math, but it's it's not easy.
Yeah, like I guess a good way of trying to figure that out is, or why these symbols actually are doing the ball is just if you try to draw pictures with a reverse triangle inequality, you basically get to that idea where whatever is in the ball, whatever is inside the ball is cannot be outside the ball, basically cannot touch things outside the ball. So I know it's hard to explain, but yeah, I hope that was helpful.
Yeah, it is. Thank you for that. This is like phoning a friend in who wants to be a millionaire.
Yeah, who wants to be a mathematician?
Hey, Skirtle. Hope you're doing well. No, I specifically avoided real analysis for my degree. I avoided any type of difficult proof-looking class, and I'm regretting it now. I did do Zach's E2 Pi Zach did do a real analysis class on Twitch though, like last year. Well, two parts, one last year, one this year. So I did those. Okay. Thank you for all of that, Slim. You're welcome to stick around, but I don't know if you want to hop back off or stick around. It's up to you.
Yeah, I'll stick around, but
Okay.
Nice.
Next one I had was number 9 then. Brought it in down below. Discrete math.
Whoa.
Oh yeah, I did a discrete math class. Yeah, this one looked complicated. Oh yeah, it was about the one that I had a question about the last time we talked, so I think that's why I grabbed this one. Dude, you don't get a 50-50 true, Zach. Matthew, it'll be a master's in applied math, thankfully, so it won't be that proofy. Okay, but Oops. Using the real Taylor series formula. Oh, formulae. Fancy. Where big O of x squared means we're omitting. Yeah. To establish the following. Interesting. This feels, I guess it's another way of evaluating a limit that they did during part of the chapter. Is why they're asking this weird thing. I sure hope it's not proofy, Dr. L. Okay, so it looks like what they're doing for the e to the z part is they're making it, well, what are they doing? They're saying z is r cosine theta plus I r sine theta.
Yeah.
So that seems no, I don't think we need a series to do that. Well, wait. Alright, we don't need a series to do any of this if we're saying z is... What?
Maybe it's this equality here where we're...
Oh, equals 0. Yeah, I guess it must be that then. Okay. I didn't even notice that equals 0 stuck on the end there. So I can see for like, we can get this to be basically a real limit pretty easily. Like that piece is already a real limit. We can take the I outside since it's being multiplied. The e's I'm not so sure about yet. Like I feel like we need to get rid of that I, but I'm not quite sure how. Maybe we need a logarithm. I'm writing this in a weird way, but oh, maybe we bring the limit up into the exponents. That's how we... are supposed to do that.
Oh, maybe. Where are we going to use the series, the Taylor series? Ugh.
This is so weird. I don't know.
Yeah, this is like that question from the first week where I didn't really get it. I didn't really know what we were trying to show. We were trying to prove that e to the z was its Taylor series, and I didn't really know what we were allowed to do and what we weren't allowed to do.
Yeah.
I think they don't want people to use that. We already know that ex converges to 0 and cos x converges to 0 and x goes to 0 or whatever. So they wanted probably to replace the exponential with 1 plus x, like whatever you have in the argument. So so instead of e of r cosine of theta, they want 1 plus r cosine of theta plus the other term, which is order of.
Oh, there you go.
But it's
Hmm.
I mean it's just gonna give you 0.
Yeah, I mean, from saying that, I could, yeah, we can see the result right away, right?
yeah.
But the I is in the exponent for the sine theta part, which is what I don't like.
Yeah, that's true. Hamiltonian dynamics suggest to use Euler's formula on the I, on the exponential, since r sine theta is real.
Huh. That could work. So I guess the e to the r cosine theta is going to be 1 plus r cosine theta. I don't know. I guess we can keep the big O. I don't know if it's that important. So we're gonna have a sine of sine or something with Euler's formula here. E to the I theta is cosine theta plus I sine theta. So it's gonna be cosine of r sine theta. Plus I sine of r sine theta.
Uh-oh.
That could work though. We're just gonna get like composition here with the series, right? And the other stuff, like the -1 stays put. I think we can say the other two limits go to 0. So we really only have this stuff here to worry about. Sponders, I don't like that because there's an I in the exponent. They specifically said real Taylor series. Yeah, I think we just expand it twice, like Hamiltonian dynamics is saying. Just use the magic of copy and paste. Theta. Blech. Wait. Okay, yeah. I need a third parentheses though. It's that, and that. Okay.
Is this sine theta here? You still want it here?
I mean, I don't want it there, but the formula they. Wait, am I doing this right? Oh, you're right. It should just be theta, I guess. Yeah, it's just theta because I'm expanding the sign. That'll be theta squared. Just looks annoying, but hopefully it cleans up. Same expansion here. Can we just expand the cosine because we only care about r? Yeah, I was worried about taking the limit too early because it's a product of two things. Oh wait, actually, I mean, at this point, we can just take the limit, though. We should just get one, and that's a good thing. I probably did some more work than necessary here, but that one stays put. That goes to 0. That goes to 0. This thing is just 1. The sign goes to 0. So I think we just get 1 because from the 1 times the 1. So we get 1 minus 1, and that's 0. That feels like a very awkward way of showing this, but I think we did it. And they want us to use what we just did to do the limit in part B.
So I think that instead of like doing all the operations, probably it's easier to take the limit on the Taylor series and then just use properties of limits, like multiplications of limits is limit of multiplications and all that, right? So basically just saying that as soon as everything is real inside the functions, you can just basically do whatever you already know, right?
Okay.
Yeah, because that seems like a mess to actually do the operation. Seems like very messy.
So
we want to multiply by cosine minus I sine then? Is that the first step?
I mean, that's what I would do.
Okay.
instead of rewriting that entire thing, let me just copy it. So multiplying, I said by cosine minus I sine. It sure is unreal.
Yeah, for the denominator, you can just cancel the cosine plus I sine because that's gonna be just one.
Conjugates, right? Okay.
You get cosine square plus sine square, so that's just one.
Nice.
Okay, but the top is what I'm worried about, I guess. E to the r.
Yeah.
Cosine theta. I'll insert the cosine theta now that we're multiplying in. Oh wait. Okay, so that minus 1 on the end will need a cosine theta also. Cosine of r sine theta. Minus cosine theta. That's the first multiplication. Joseph, is this book good? So far, not very. One that probably be better is visual complex analysis. I'm using this book for sort of reason that a class I'm going to take is going to use it. But if I was just studying it for fun, I'd probably be using that book. Leave it factorized, Hamilton Dynamics says. That would save a lot of writing.
So if you're gonna use properties of limits, you can already cancel the ER cosine theta and the ER cosine theta because those are gonna be 1 anyways.
Sure, yeah. Like I said, yeah, I don't see where this is leading, but
I think that the only thing that we kind of need is to prove that in the numerator you're gonna get an R that is gonna cancel with the R in the in the denominator.
Hmm.
Okay, I guess that's what we end up with if I don't multiply it out. And so we're gonna start expanding things. And that's how we get our R to cancel.
Well, that's the hope.
Okay. uh, okay, so the cosine become 1 plus
Yeah,
big O.
actually, yeah, it's like if you scroll down,
Oh,
like in the
I-
part that you were doing. So I think you don't need to care about doing the carrying out the multiplication. What's going to happen is that if the cosine R sine theta, if you replace the Taylor formulas with the -1 that you get there, the -1 is going to cancel. So because
oh,
cosine is one plus order of something, right? So the
Mhm.
-1 is going to cancel
Right.
with that, yeah. Yeah, and then you can cancel that.
But then aren't
And
we just going to get 0?
I think that's the goal. Yeah. Well, I'm not sure if we're going to get 0, but we are going to get the R's cancelled, which is what we want.
You can see the R's canceling? I don't see it yet.
I think, yeah, I think so. I think
Okay.
that I mean,
I think they
without
will.
performing the without performing the multiplication, because anyways you will need to factor out an R. So there, yeah, there's the 1 and -1 cancel, and you already have the I mean, you put an extra R that is not there actually. It's plus I sine theta.
Mm, that
Maybe
R
this
sine
came from
theta,
the.
it came from the inside of this. Like I expanded this sign on the outside, and I think that R does go there.
Oh. Oh, okay. Yes, yeah. See what you're saying. Yeah, expanded that already. Yeah.
I was hoping these big O things would cancel. I don't know if we can just ignore them, but that would, I think, give it the cancellation you're talking about, though.
I mean, no, they're not going to cancel, but you're going to ignore them basically, because since R is going to 0, R squared goes faster to 0, so you kind of cancel them. You kind of ignore them. But yeah, so the 1 and -1
So, yeah, I mean,
cancel.
yeah. That means we kind of just get IR sine theta if we let the big O's just be 0.
Yeah. So yeah.
And then,
So I think that's fine.
was that? No, it's a minus.
And the R is already canceling there.
Yeah.
Yeah.
So we get
Okay.
I sine theta cosine theta plus sine squared. We're supposed to get 1. Are these magically 1?
No, that's not 1.
They almost would be if we just had a slightly different trig identity to use. But no, there won't be 1 here.
Well, I think it's a minus, right? And then it's actually sine theta cosine theta minus sine square.
There's an I times an I.
Oh, yeah. Can see that.
And then that wouldn't quite fix it. That's the original expression there.
But in the expansion of sine, you also have a 1, don't you? No, you don't. X plus 1.
Oh, it's annoying. That's something we didn't really use part A. I was trying to look for a way to insert that, but I can't really find it. Sometimes saying to expand the exponentials.
Yeah. I was looking at those too, but because we just sort of got rid of them, but I don't see how it's going to do anything.
I think we'd end up in the same spot.
We sort of factored out that e to the r cosine theta and just got rid of it. But it seems like when r goes to 0, it's just going to go to 1, no matter how you look at it.
Yeah.
Yeah, the e to the r cos theta. I don't know. Does it do something?
I don't think it should do anything.
The term proportional to r in the expansion of a cross term with the 1 from cosine.
No, it does something actually because
it?
because it's only multiplying the cosine, and I'm sorry, my bad, I misread that. I
Oh,
thought it
it's
was
not.
multi-
It's not hitting the -1. Oh,
Yes, yeah,
right,
yeah.
right. Oh,
So
yes, we
that's the
can't do
problem.
that.
Yeah, so it's
Ah,
you cannot cancel them. Yeah, that's my bad.
Oh, but so the e isn't being multiplied with the -1.
no,
But
that's the problem. So this. So, yeah. So how do we fix this?
so that was, oh my god. Get out of there. Okay. So e to the r cosine theta is gonna be 1 plus r cosine theta. I'm just gonna chop off anything with big O right now out of laziness.
Nice.
But I need it also with the sine, I guess. Okay, and so I'm just gonna start multiplying things and hope this fixes it, because I wasn't following. Oh, that's the minus one that doesn't cancel. Okay. I see now. Should I be, I guess I should be expanding the cosine of r sine. No, is that what I just did? Maybe that'll be the next step. It's a big fraction.
I don't know. No, I'm confused again. Keep going. Keep going. I'm confused again.
I mean, my keep going is just to expand the trig of r whatever.
Yeah. Yep. I agree.
Okay. So cosine will be 1 plus. I'm just not dealing with big O's, so cosine of r sine theta is about r sine theta. Yeah. No, it's just 1. Cosine, that becomes 1 minus 1 plus I plus r cosine theta. Sine of x is about x, r sine theta. Oh, the r's cancel now. Again. Cosine theta plus I. Okay. I canceled an R. So we don't have a fraction anymore. Now we can let R go to 0, and that gets rid of that.
You got it. I
Yeah.
think you got it.
Yeah, that's it.
Oh, okay. This will just be 1. Oh my gosh. Great call, Hamiltonian dynamics. All right. That one's a doozy. We're nearly at the 2-hour mark. The next one, I can see from the screenshot, it looks a little bit long. We can read it and decide if we want to do it, I guess. I did pull one differential equation one.
Oh, fun.
So they give us a second order diffie-q. Okay, this one, it doesn't look short. It doesn't look like it's gonna be just a few minutes. I'm still here for it though, but if you guys want to dip out, it's on you. Or it's fine.
I mean, it doesn't seem too hard actually. I think that
Yeah.
the previous one was harder.
Okay.
Yeah, let's check this out. Let's check this out.
Okay. So what's going on for part A? Show the transformation x equals e to the t. Is it just me, or does this expression make no sense?
They're operators. We're trying to prove these operators are going to do the same thing.
I guess so.
Isn't that what that means? So
Uh,
it means like x times the derivative with respect to x of something would be the same as the derivative with respect to t of that same thing. I think that's what we want to show. Well, if x is e to the if x is e to the t, then dx dt equals x, right?
dx. Wait. dx equals e to the t?
E to the t.
Well, they told us in part A that x equals e to the t.
Yeah, and now you.
So if that's the case, then dx dt equals e to the t, which is x. So what does that mean?
Now et is equal to x.
Say that again, Slim.
Et equals x, so you get dx equal x dt, and then just move things around.
Yeah, divide it over. Okay, that seems okay. I get it.
Oh, this is
So
no.
you sort of flip it, and then you put a d on top of it. Is that legit?
No. This
X
is
times
terrible.
1 over dx.
You just what you need to do is you multiply by d on both sides, right?
Yeah, you multiply by d. I know. Yeah, that's what you do.
Hamiltonian dynamics has a better explanation using chain rule.
Okay, I don't like this at all.
Thank you. Yeah, the chain rule is what we want. So ddt is ddx times dx dt. Yes. Beautiful. Simple as that.
Oh, and dx dt is x. Okay.
Is x right here, yeah.
I way prefer that argument. Oh my god. Okay. Scaldra's dying.
Now what do we do? Take derivative with respect to t of both sides, I think. Is that the way to do it? No.
Fundamental theorem of physics, derivatives are fractions. Okay. It sure looks like another derivative. Yeah, I bet it is like a product rule on the right-hand side. And we're gonna turn a d by we're gonna turn something back into t's or something and subtract it over. That's my bet.
Yeah, let's try it.
What derivative are we taking? Of each side. Yeah, we're skipping problems, responders. So this is section chapter 1.3, number 12. I think I don't even know if there's more than one edition. Oh, it's second. So maybe we're taking the derivative with respect to t of each side, but we're gonna
I like that.
change one of them to be an x, right?
Well, x depends on t, right?
Oh wait, I meant this to be an x. But I think this is, if the operators are the same, we can do this to each side of the equation. That's my thinking. D by dx plus x. There you go. And this x dx will be turned back into a d dt.
Shouldn't that be a? Shouldn't this be a 1 here? Let me see. Product order. Isn't this a 1 here?
I took the derivative of
No.
x, which became
No,
1.
no. Yes. Yes. Okay, I see it. Sorry.
No worries.
I think you did UDV plus VDU, and I'm thinking VDU plus UDV or something.
Oh, okay.
Yep.
I think that's it. For
Yeah,
A.
beautiful.
And so all this was to justify, I guess, a change of variables in part B. Okay. So then, I think this is pretty direct for part B.
Yeah.
So the x squared, that thing becomes dt.
Yep.
And then
I guess use the first one for the second term, maybe.
yeah.
Plus W equals 0. Oh, and they cancel.
Nice. And then use that result to establish W has the real solution. So we should solve this in T and then get it back in X, I guess.
So wait a second. Now we got, so part B, isn't that just a damped harmonic oscillator or undamped? That's an undamped,
Yeah,
right? Isn't
I
that
think
just sines
so.
and cosines come out of this one?
Yeah, I mean, I think we want to take W
Second derivative.
like equal to complex exponential, but yeah.
If the second derivative of a function is its negative, then it's a sine, it's made up of sines and cosines, isn't it?
Yeah.
So wait a second. This thing we started with is the same as this. Well, we did a transformation. X is e to the t.
Yeah, I don't quite know if that has a meaning or not. Like a physical.
Yeah, what does that mean? So does that mean if x is e to the t, then, oh, all right. Sorry, I'm just thinking out loud.
No, I was wondering about that too. I don't really know what it would mean though.
So as Fenbox said, the solution should be W equal A cosine of t and B sine of t.
Oh,
And
logarithms.
then,
Yeah.
but x is equal to e to the t.
You
So if you
take
want
the
to,
log.
Yep.
Yeah. Wow.
Like reparameterizing time. I guess that's what it is. I'm seeing confused as X is usually for space and T is for time, but it wouldn't make sense to make those things equal. So we have to make a choice for what's what.
Yeah, so, right. So,
I mean, I don't feel like we need to actually go through and solve that differential equation. I feel like we are pretty familiar with this result for
yeah.
that. This is base E, I guess. I really hate log with no base for ln, but you can do it. And presumably we could mess with this enough to get the first version of the result, they say, or proceed directly from like taking W equal to a complex exponential, but I feel like we don't need to do that.
I guess what's interesting is that on the first form, you only get C instead of A and B. So you only need one constant if you do it in the first form.
Right.
But yeah, like the way to get the first form would be to assume that there's like a complex exponential solution, and then you would get something like that.
Yeah.
Okay. Well, nicely done.
So this was an interesting question.
Yeah, that transformation is kind of interesting.
Yeah, yeah. If I hadn't had this part A here to spoon feed me, I don't know if I could have solved that differential equation. I don't know. I would have known how to do it with these, where it's like non-linear like that. X equals e to the t.
There's like a pattern though. It's like x squared with the second derivative and x with the first. I would
Yeah.
have looked for some change of variables. I don't know that I would have figured out that one though. Thing comes in physics somewhere. Hamiltonian even says, okay. Physics class for ODs never saw it again. Okay. Well, nice. I guess I was thinking about what we can do for next time. Chapter 2, the entire thing is very long. It's like 70 pages, so we shouldn't have to read the entire thing by next week, but I want to skip over the starred content because it's marked as optional and I want to save time. And so for next week, I think it's hopefully reasonable to do 2.1, 2.2. I mean, there's 5 sections that aren't starred. That's annoying. What's the page count? I should have figured this out separately. I think 2.1 and 2.2 are pretty long. It's like from the page count. So maybe we'll do just those first 2 sections for next week. And then the week after can be the other 3 sections. But we can always adjust at the time if we need. Okay. Well, yeah, that's all problems I grabbed for chapter 3, so we got through them all. That's awesome.
Brilliant.
Well, thank you both for being here.
Thanks for having
Yep.
me.
Yeah. Guess I'll see y'all later.
All right.
All right. See you guys next time.
All right, bye. Noish. Black Schultz Fish. I don't think I've heard of that one. These are pretty fun sessions. Is that loud? No, it's not loud. I'll still stream for a bit more, I think. Actually, wait, let me see. I don't stream for much longer because of my voice, but we'll go for a bit longer. Just write an announcement before I forget. Uh, 2.1 and 2.2 next week, then 2.4 to 2.6 the following. Okay. It's this one right here. I don't particularly like it, but the class that I'm going to take for my master's is going to likely use this book, so. Let me change the YouTube title and category. Okay. I think I'm all switched over. I don't think there's anything posted on the Discord that's pending to be answered. Let me unpin that message. Actually, I kind of want to keep these just in case. You know what should I do while we hang out for a bit? I could do some more. Could choose another question from the same book. You know what? There is something that I haven't done before. I want to figure out how this works because I've heard from others it's a like I know that Zach uses this way to remember trig identities. And I'd like to learn it. The face portraits, yeah. It's looking real good. Because I'm not sure if I'm actually gonna end up using it, but it's still fun to make. Oh, you can do it for any. I didn't realize you could do it for like a quadruple lingual and higher. Okay, so how do we want to do this? We want to. This looks terrible. You had to use it? Oh my god, I've never had to actually use it, I don't think. Oh, this. Oh my god. I see the trick. We're gonna equate coefficients, right? Yeah, I'm surprised you even had to use it once. This is actually, I didn't realize it was this easy. This is really just another thing that comes down to like binomial expansion. I'm on this like a hobo on a ham sandwich. Exactly what I'm like right now. I haven't heard that one before. Okay, well that was a lot easier than I thought it'd be. What about the second part? Oh, this is just... Okay. You just take x1 equals to x2. This is boring. This is too easy. I shouldn't make that complaint because it's gonna... I should be careful what I wish for here. Oh, hell yeah, color cone. Yeah, like I have two playlists that are like my favorites for stream. I sometimes switch it up beyond those two, but this is one of them. What about number 8? Oop. There. Feels like a polar form question. Oh yeah. Um, um, Intuitively, it makes sense to me that this term is more important if r is more than 1. And so the negative angle from here shouldn't really affect things. Or it's not going to affect it enough to change the quadrant, I should say. Or well, if we know it's in quadrant 1 or 2, we're going to stay in quadrant 1 or 2 despite having this take away from the angle or mess with it in some way. I guess it'd be taking away. How would I actually show it? Like, should I... Not enough ghosts. That's true. Maybe it's better. So I wonder if polar isn't actually the way. Guys, maybe not immediately. You may want to do this first. Is it worth getting common denominators? Actually, maybe. No. No, I don't think it is. Is it though? What can I say about this? Just the way it is. Uh, this is basically r squared. I haven't heard about 10 seconds of this song and I already kind of love it. I don't know why the feeling my brain just like went off. Uh, this is a positive number. I assume that's enough. Like, I guess I haven't shown it, it's the entire upper half plane, but I've shown it's at least somewhere in the upper half plane. Um, I feel like it's, I don't know. I'm just debating how I could show it's the entire graph plane, but I don't know. I'm getting lazy, I guess. Yes, you say something about that function with for the imaginary part being any number. That's basically what I did. Like, that right there is U. That right there is V. And I noticed that there's a hidden R right there. R squared. Oh, X of UV. Oh. Really? I mean, I don't think so. The question says, like, given y is greater than 0, and that show that v is greater than 0. I mean, it should be the entire graph plane, which it's kind of sketching whether I've actually done that, and not just a portion of it, but... I mean, why would getting y of uv do that for us? If it would. I don't think it would. I don't know. What about 7? Feels like a Taylor expansion. The point is, all these go to 0. So we just end up with 1 minus 1 is 0. What about you? What about you? I guess same idea. Taylor expand. Oh, wait. That's not good. Never mind. I'm done. What about that? No, not that. That. Wait. F of z is a complex number. This isn't valid, I don't think. Or, I don't think it's valid. This feels like a hidden derivative. Like, what would this function be? Young Wayne, thank you for the follow. Maybe it's not a derivative. I don't know, man. I guess so, Moober, just to try and get some type of clue here. As long as this is true, we can pick a function we want. This feels like 1. If it was a real number, it would be 1, right? That's an issue, though. If we're getting two different results. It is 1. We're doing the second part of number 7 here. I do think the answer should be 1. This example that Lubert brings up seems like a problem. But I feel like except for that, we should always be getting 1. I'm just trying to... I don't know how to justify that, though. I guess let's try it. I don't know what this one is. I seen this series. Oh, that doesn't... No, it does. This is 0, isn't it? No, no. This is diverging. No, or is it? I don't know. I don't know what this is. Do they? That'd be great. Maybe I need to reread this. Ooh, there's that. Okay. Yeah, I think that's what we need then. That makes life way easier. Wait, okay, so let me follow along with Velopidal's idea. But I want to look into your thing too, color cone. Is that why we were getting different results? It's actually okay? No, wait, this is that's not good for... No, it is good. Never mind. Huh. What happens with your idea? We don't know. Hmm. Would we be back to Lopidals there, color cone? Like, it can. But I think with Lopidal idea, like, we found a formula for it, though. It should always converge. So this is a derivative, actually. Oh my god. Oh, it requires F to be smooth. So maybe I wonder if their intention was to notice this, that it's the limit definition of a derivative. I think that's what they wanted us to do, probably. The derivative at 0, right? Even make the limit diverge. Hmm. True. That's a pretty sneaky choice. I can see where it comes from, though. I wonder the book's answer will say. Because I imagine what I found with the derivative is probably what they intended, or maybe the L'Hopital's thing. It's number 7? Yeah. Oh, lazy. You only give the answers to number 1? I got scammed. Oh well. Okay. We might wrap it up here for the day. Famous textbook trick to save paper. Yeah. Answered only to the odd number exercises that we feel like working out. I can't believe it. Oh well. Actually, I can absolutely believe it. Okay. I'd love to keep on streaming, but for the sake of my voice, I should really try to cut myself off before I want to. So yeah, I think that'll do it for today. We got a lot of good complex analysis done, though. I'm excited to be learning more about this. It just kind of seems like a fun subject. So yeah, people who are on YouTube, thank you for being here. I'll be back on YouTube on Thursday is the plan. So goodbye, YouTube.